A signal from deep space, a planet that defies all expectations, and a race to another star. What if everything we thought we knew about the universe is about to be shattered? The James Webb Telescope has uncovered secrets so shocking that they could rewrite the rules of life itself. But is Proxima B truly a new Earth or a deadly trap in the vastness of space? The James Webb Space Telescope, often hailed as humanity's most advanced eye in the sky, has recently turned its gaze toward one of the most intriguing exoplanets ever discovered, Proxima B. This distant world orbiting the red dwarf star Proxima Centauri has captivated scientists and enthusiasts alike since its discovery, but now with the unparalleled capabilities of the JWST, we are finally getting a closer look at this mysterious planet, and the revelations are nothing short of extraordinary. Proxima B was first detected in 2013, but it wasn't until the James Webb Telescope came into the picture that we could truly appreciate what lies on this distant world. The telescope's ability to capture infrared images has allowed astronomers to peer into Proxima B's atmosphere, revealing details that were previously hidden from view. And what they've found has sparked both excitement and concern. You see, Proxima B orbits its star at an incredibly close distance, just 7.3 million kilometers away, less than 5% of the distance between Earth and the Sun. This proximity means the planet completes a full orbit in just 11.2 Earth days. But what makes this even more fascinating is that Proxima Centauri, the star it orbits, is a red dwarf. Unlike our Sun, which is relatively stable, red dwarfs are known for their volatile nature, often emitting powerful solar flares that can drastically affect the planets orbiting them. Now here's where things get even more interesting. The JWST has provided the clearest image yet of Proxima B, and it's revealed some startling features. For one, the planet is about 30% more massive than Earth, meaning it has a stronger gravitational pull. But what's truly shocking is the possibility that Proxima B is tidally locked with its star. This means one side of the planet is in perpetual daylight, while the other is shrouded in eternal darkness. Imagine a world where the sun never sets on one side, while the other is plunged into an endless night. This tidal locking creates a harsh environment for any potential life forms. The side facing the star would be scorched by constant radiation, while the dark side would be a frozen wasteland. This raises a critical question: could life ever survive in such extreme conditions? The possibility seems slim, but nature has a way of surprising us. But the challenges don't stop there. Proxima Centauri itself poses a significant threat to the habitability of Proxima B. The JWST has revealed that the star is far more active than previously thought, with powerful magnetic fields producing intense solar flares that bombard Proxima B with high-energy radiation. In fact, a flare observed in April 2021 was 100 times more powerful than any flare ever seen from our Sun. Such a massive burst of energy could strip away the planet's atmosphere, leaving it exposed to the harshness of space. Some researchers argue that Proxima B's proximity to its star and the frequent solar flares make it unlikely to support life as we know it. Others, however, suggest that life might find a way to adapt to these extreme conditions. Could there be organisms on Proxima B that have evolved to survive in such a volatile environment, or is the planet doomed to remain a barren rock devoid of life? As we continue to explore Proxima B with the James Webb Telescope, more secrets are sure to be uncovered. But one thing is clear: this tiny planet, just 4.24 light-years away from us, is far more complex and enigmatic than we ever imagined. Could it be that Proxima B holds the key to understanding the limits of life in the universe, and if so, what does that mean for our search for extraterrestrial life? Proxima B's stunning secrets revealed one of the most shocking discoveries was the planet's atmosphere, or rather the potential lack thereof. The intense radiation from Proxima Centauri, combined with the planet's close orbit, means that Proxima B is constantly bombarded with solar wind and high-energy particles. Over time, this relentless assault could have stripped away the planet's atmosphere, leaving it barren and exposed to the cold vacuum of space. But here's where things get interesting. Some scientists believe that Proxima B might still retain a thin atmosphere, possibly composed of heavier gases like carbon dioxide or nitrogen, which could provide some level of protection from the star's radiation. The James Webb Telescope has given us the clearest glimpse yet of Proxima B's surface, and what it has revealed is both fascinating and mysterious. The planet's surface appears to be rocky, much like Earth's, but with significant differences. For instance, the side of the planet facing Proxima Centauri is likely scorched by constant heat, creating a barren desert-like landscape. Meanwhile, the dark side of the planet could be a frozen wasteland with temperatures plummeting to levels far colder than anything experienced on Earth. But the most intriguing possibility lies in the narrow strip of land between these two extremes known as the twilight zone. This area where day meets night might offer more temperate conditions where liquid water could exist. The existence of liquid water is of course one of the key ingredients for life as we know it. Could this twilight zone harbor a hidden oasis where life has managed to take root despite the harsh conditions on the rest of the planet? Another stunning revelation came when scientists examined the possibility of water on Proxima B. If water exists on the planet, it would likely be in the form of ice on the dark side or small, possibly temporary bodies of liquid water in the twilight zone. But the discovery that shocked many was the potential for subsurface oceans similar to those found on moons like Europa or Enceladus in our own solar system. These oceans could be heated by the planet's core or by tidal forces caused by Proxima B's close orbit to its star. If such oceans do exist, they would be a prime location to search for life hidden beneath the planet's icy surface. But let's not forget the potential challenges. The magnetic field of Proxima Centauri is another factor that adds complexity to the planet's environment. Recent studies suggest that the star's magnetic field could interact with the planet's core, generating its own magnetic field. This interaction might protect the planet's atmosphere from being completely stripped away by solar wind, much like Earth's magnetic field protects us from the sun's radiation. However, the situation on Proxima B is far from straightforward. The star's powerful flares could overwhelm the planet's magnetic defenses, leading to dramatic and sudden changes in the planet's climate and surface conditions. These discoveries raise more questions than answers. If Proxima B does have a magnetic field, how strong is it and how does it influence the planet's atmosphere and potential for life? Could life on Proxima B have evolved to survive the planet's harsh and fluctuating conditions? And if life does exist, what form would it take? Would it be something entirely different from anything we've seen on Earth, or could it share similarities with extremophiles that thrive in Earth's most inhospitable environments? While the idea of a habitable planet orbiting Proxima Centauri is captivating, the reality is far from hospitable. The James Webb Space Telescope has provided unprecedented insight into the challenges any potential life on Proxima B would face, and the picture is anything but rosy. One of the most significant challenges is the planet's exposure to extreme levels of radiation from Proxima Centauri. Unlike our Sun, Proxima Centauri is a red dwarf star with a much smaller mass and a much more chaotic surface. This star's proximity to Proxima B means the planet is constantly bombarded with intense solar radiation, including powerful flares that can be 100 times stronger than those emitted by our Sun. These flares produce a deadly cocktail of ultraviolet and X-ray radiation that would be lethal to any life form similar to those on Earth. The effects of this radiation are not just theoretical. In April 2021, a particularly massive flare from Proxima Centauri was detected, and it was strong enough to potentially strip away any atmosphere that might have existed on Proxima B. This event serves as a stark reminder of the dangers posed by red dwarf stars, and it casts doubt on the likelihood of Proxima B being a haven for life. Moreover, the constant exposure to such radiation would make the surface of Proxima B an incredibly hostile environment. Any water on the surface would be rapidly vaporized, and the planet's rocky landscape would be scorched by the relentless heat. The dark side of the planet, while not exposed to direct radiation, would be equally inhospitable due to the freezing temperatures. This extreme dichotomy between the scorching day side and the frozen night side leaves little room for a stable, life-sustaining environment. But the challenges don't end there. The James Webb Telescope has also revealed that Proxima B is likely tidally locked to its star. This means one side of the planet is perpetually facing Proxima Centauri, while the other side is in constant darkness. This tidal locking creates a scenario where the planet's atmosphere, if it exists, would be subject to extreme temperature differences, potentially leading to violent winds and storms as the heat from the day side attempts to balance with the cold of the night side. These harsh conditions would make it incredibly difficult for any form of life to gain a foothold on the planet. And yet, despite these challenges, the possibility of life cannot be entirely ruled out. Some scientists have speculated that life might exist in the twilight zone, the narrow region between the day and night sides, where temperatures could be more moderate.